Hello everyone. If we are given the graph of a function instead of its expression, how do we extract information from it? That's exactly what I'm going to show you in this video. I will show you how to find the domain of definition and the range of this function, how to calculate f of a certain value, how to solve equations of the form f of x equals to a, or inequalities, and how to find the intervals where f is increasing or decreasing, and finally, how to solve equations or inequalities involving two functions f of x and g of x whose graphs are given. Let us start with exercise 1. So we are given the graph of a function and we have to answer the following questions. Let us start with the domain of definition of f. As I explained in a previous video, it is the set of all possible input values. In other words, it is the set of all values of x. If we look at the graph, we notice that there is no cut, neither there is a hole. In other words, no matter where you draw a vertical line, it is always going to intersect the graph, which means we will always find a corresponding value of x. Since there is no cut in the graph, neither there is a hole, this means that the domain of definition of f is all real numbers, minus infinity up to positive infinity. Similarly, if we draw any horizontal line, it'll always intersect the graph at least one point. Therefore, the range of f is also all real numbers. Let us move on to part B. We are asked to calculate f of 0. Let us always keep in mind that y is equal to f of x. So either I'm giving the value of x and I have to find the value of y, or I will be given the value of y and I will be asked to find the value of x. Now here we are asked to calculate f of 0, which means x is equal to 0. Therefore, we are asked to calculate the value of y. How do we do that? We look at x equal to 0 and we draw a vertical line. We keep going until we hit the graph, and it hits the graph at minus 2. This means that f of 0 is equal to minus 2. In other words, if x is equal to 0, then y is equal to negative 2. In part C, we are now given the value of y, and we are asked to calculate the value of x. So the first equation is f of x equals to 0. Thus, we look at y equal to 0, it's here, and we now draw a horizontal line and see where it intersects the graph. It intersects the graph at x equal to minus 2 and at x equal to 1. This means if f of x is equal to 0, then x is either equal to negative 2 or x is equal to 1. Similarly, if f of x is equal to negative 4, this means if y is equal to negative 4, what are the possible values for x? Let us draw a horizontal line at y equal to negative 4, and we get 2 points. The first point has abscissa at x equal to negative 1, and the second point has abscissa at x equal to 2. This means x is equal to negative 1 or x is equal to 2. Let us move on to part D. Here we have two inequalities. The first inequality is f of x is greater than 0, which is equivalent to y is greater than 0. This means we have to look at the region above the x-axis and see where there is a graph. This is the part of the graph where y is greater than 0, which means that these are the values of x where y is greater than 0. So x starts from negative infinity up to minus 2 excluded. And why is minus 2 excluded? Because the question says y is greater than 0, not greater or equal to 0. Now for f of x less than 0, which means for y less than 0, we have to look at the graph underneath the x-axis, and this is the region where the graph is below the x-axis. So we start from negative 2 up to 1. We have to stop at 1. Why? Because at x equal to 1, y equals to 0. And again, we do not have an equality. It's a strict inequality. This means we have to exclude the 1 from the solution, and then we continue from 1 up to positive infinity. So this means x belongs to minus 2, 1 open, union 1 open, up to positive infinity. We can also write our answers in the form of inequalities. So for the first question, we can write x is less than negative 2. And for the second question, we can say that x is between minus 2 and 1, or x is greater than 1. Both expressions are equivalent. In part E, we have to find the intervals where f is increasing, then decreasing. When we say f is increasing, this means we have to look at the part of the graph where it's going up. And we are talking about this piece of the graph, which starts right after -1 and stops before 1. This means f of x is increasing for x belongs to -1, 1 open, or equivalently, we can say x is between -1 and 1. What about the intervals of x, where f is decreasing? We are talking about this piece as well as this piece of the graph. So the values of x start from -infinity up to this point, which is -1, then starting 1 up to +infinity. This means f of x is decreasing for x belongs to -infinity up to -1, union 1 up to +infinity, or again equivalently, x is less than -1, or x is greater than 1. We now move on to number 2. I'm going to answer the same questions for a different graph. We now start with part A. We have to find the domain of definition as well as the range of f. For the domain of definition, we notice that there is a cut at x equal to -1 as well as x equal to 3. This means that the domain of definition of f is all real numbers except -1 and 3. So the domain of definition is, that's the first part. We start from -infinity up to -1, open of course. This is the second part, so it's union -1 up to 3, open, and this is the third part, so union 3 +infinity. What about the range of f? No matter where I draw a horizontal line, it'll always intersect the graph at least one point. This means that the range of f is simply all real numbers. Now, what is f of 0? In other words, what is the value of y for x is equal to 0? For x equal to 0, we draw a vertical line and we notice that it intersects the graph at y equal to 0. This means that f of 0 is equal to 0. What if y is equal to 0? If we draw a horizontal line at y equal to 0, it intersects the graph at x equal to 0. This means f of x is equal to 0 gives us x equals to 0. Now, f of x is greater than 0 means y is greater than 0. So I am talking about this part of the graph as well as this part, which means at x between -1 and 0 and greater than 3. So x belongs to the interval -1, 0 open. Again, why open? Because we do not have an equal sign. It is a strict inequality. Union 3 up to +infinity. On the other hand, f of x is less than 0. It means where the graph is beneath the x-axis. So we're talking about this part of the graph and this part. This means it is all the values up to -1 open, as well as all the values between 0 and 3 excluded. So x belongs to -infinity -1 open, union 0, 3 open as well. Now, is there any part of the graph where f is increasing? We can see that there is no part where f is increasing here. F is decreasing everywhere. The graph is going down everywhere. This means f of x is decreasing over the entire domain of definition. For x belongs to -infinity up to -1, union -1 up to 3, union 3 up to +infinity. So since f is always decreasing and never increasing over the domain of definition, we say that f is strictly decreasing over its domain of definition. We move on to the last question I will do in this video, and here we have two functions. We have a function f, whose graph is the red curve, and another function g, whose graph is the blue line. In part A, we are asked to solve the equation f of x equals to g of x. This means we have to look for the points where the two graphs intersect. Thus, we are talking about this point, and this point. So f of x is equal to g of x if x is equal to -1, and I'm talking about this point, or 0, I'm talking about this point, or 1, and here I'm talking about this point. Now, what is meant by f of x is greater or equal to g of x? This means we have to look at the part of the graph where the graph of f is higher than the graph of g. And since we have an equality here, we should also include the points of intersection. So where is the graph of f higher than that of g? It is this region as well as this region. The first region starts from -1 up to 0, and the second region starts from 1 up to positive infinity. Thus, f of x is greater or equal to g of x if x belongs to -1, 0, and here we have to close the interval. Why? Because as I said, we have an equality here. Union the other region, which is 1 closed up to positive infinity. The next inequality is f of x less than g of x. So here we have to look at the part of the graph where the graph of f is below the graph of g, and we are talking about this region as well as this region. The first region is between -infinity and -1, and the second region is between 0 and 1. Since there is no equal here, I mean, since it is a strict inequality, we have to open the intervals. So x belongs to -infinity, -1 open, union 0 up to 1 open as well. This is how we solve functions graphically. Thanks for watching, and see you in the next video.